Hello and welcome to this new tutorial. Alright, so we got the final shape of the output, the stochastic output, as opposed to the deterministic output that we got in the previous tutorials, and now we're ready to get the MDN coefficients. So before we get them, let's jump back a bit into the theory to remind ourselves what they are. And so I've prepared some good resource for you, which is right here, this PDF by Sargor Srihari, which explains everything about mixture density networks. But what I only want to show you right now is just a reminder of what the parameters of a mixture density network are. We can see them a bit below. Here they are. The parameters of a mixture model are first the mixing coefficients, second the means, and third the variances. And that's exactly what we're about to get inside a function which we will call getMDN coefficient. Alright, so let's do this. Let's go back to Python. Here we go, and let's implement that function. So first, it's important to explain here that we're not about to make a method, because we're already inside a method. We're right now implementing the build model method. So what we're about to do now is a function inside the build model method. And so, again, we start with def to define this new function, which we're going to call getMDN coefficient, or coef, which will take as arguments not self, because it is just a simple function, but of course the output, because we're computing the MDN coefficient from the output. And the way we're going to do this is we're going to split the output in three parts along the horizontal axis, meaning along the dimension of index 1, and each of these parts will be used to compute each of the three coefficients. And we won't compute now the mean and the variance. This is done in some other parts of the implementation, but we will already include the formula for the mixing coefficient, which is the first parameter here. So let's do this. Let's first split the output in three parts, three equal parts, and for this we're going to use the tf.split function, which I've prepared here for you in the TensorFlow documentation. So here we go. The tf split function takes a couple of arguments. The first one is the value, meaning what you want to split, and this is going to be, of course, our output, the stochastic output resulting from the MDN RNN after the MDN output layer. Then the number of size splits, meaning the number of splits you want to have from your output, and this is going to be, of course, 3, because we want to split the output in three parts, one for each of the three MDN parameters. And then the axis, and the axis is along which axis you want to split your output. And so we want to split it along the horizontal axis. Remember, our output right now is a 2D tensor, so we're going to split it along the horizontal axis, meaning we're going to split it along some buckets of observations, right? Because the rows correspond to the observations or the samples. All right, and then the last arguments, we don't really care. We're going to keep the default values, and therefore here we go, we're ready to use that function. So since this tf split function returns the part resulting from the split, well, we're directly going to introduce here the variables that will represent these splits, and since each split corresponds to each one of the three MDN parameters, well, that's exactly what we're about to introduce here. So the first one is going to be log mix, which is for the mixing coefficients, the first parameter. Then the second one is going to be the mean, and the third one is going to be the log STD, standard deviation. So we're taking the log here, which is a classic thing to do in mathematics. Working with the logs of the parameters will facilitate the operations, including some exponentials, which is the case for the mixing coefficients and the standard deviation, which is the root of the variance, which we've got here as the third parameter. Alright, so this is what is going to be returned by the tf split function. So now it is the time to call it. And so I'm getting TensorFlow first, from which I'm calling the split function, which takes, as we've just seen, three arguments. The first one is what you want to split, which is the output. The second one is the number of splits you want to get, which is 3. And the third one is the axis, the index of the axis along which you want to do the splits, which is 1. Alright, so this split is ready. And now, as we've said, we just want to include some computations of the log mix. And so for this, we're going to use another function by TensorFlow, which is this one, math reduce log sum exp, which will compute the log of the sum of the exponentials of the elements across the dimensions of a tensor. And so this tensor is going to be this log mix part of the output resulting from this split we've just made. So that's the tensor. Then the dimension is going to be again the horizontal axis, meaning the axis of index 1. So again, we're just going to take all the rows, all the observations, which are exactly these elements across this dimension of index 1. And we're going to take the exponential of each of them, then summing all of these exponentials, and then taking the final log. And so the formula of this log mix is a decrementation of this formula here, the log of the sum of the exponential of the elements across this dimension of index 1 of this log mix part of the output tensor. So we're going to write that into code right away. As we said, it's a decrementation, so I'm going to take log mix, and then a decrementation goes this way. You can do minus equals, or if you clearly want to see what's happening, you can do it this way, equals log mix minus, and then exactly this function. So we're not going to use the tf math reduce log sum exp function directly, but it's second alias tf.reduce log sum exp. So I'm going to take this, then going back into Python, going to paste this, and in the parentheses, here we go, let's input the arguments. So the first one is, as we said, the tensor inside which you want to do this log of the sum of the exponentials of all the elements across the axis. And this tensor is, of course, the log mix part of the output, resulting from one of the 3 splits that we did before with this tf split function. And so here we go, let's input that part of the output, log mix, and then remember the second argument was the index of the axis along which we want to do this big formula, the sum of the exponentials of all the elements across this dimension. So the second argument is the index of this dimension, and so as we said, it is the index 1. And finally, we have a third argument, which is keep dims. The default value is none, but we're actually going to set that to true. And keep dims, as you see, is the deprecated alias for keep dims, and that's because we're using the alias here, tf.reduce log sum exp, right? This implementation was actually not done in TensorFlow 1.12, but I think 1.10. We'll check that in the end. But if you use this, by the way, the whole implementation will still work very well. So you can do it with TensorFlow 1.12. There is no problem for that. All right, so going back to Python, here we go. Let's input that final argument. Keep dims equals true. Perfect. And now, as we said, we're not going to compute here the mean and the log std inside the 2 remaining splits resulting from the output. This will be done later, but at least we have the part of the output for each of the 2 remaining parameters, the mean and the log std. And so what we're going to do now is simply return directly these parameters with their actual form. And so the first one is log mix, then the second one is the mean, and the third one is the log std. Alright, and now that this function is ready to return these parameters in their actual form, well, let's get these parameters by calling this function. And so we are going to introduce 3 new variables corresponding to each of these parameters, starting with the log mix, which we're going to rename out log mix, because indeed this is resulting from a split of the output, out log mix, then same out mean, that's for the mean, and then out log std, and that's for the variance. And so we're going to get them by calling the get MDN coef function, which takes as argument, of course, the output, right? So this now gives us these coefficients, and lastly, we're going to put these variables into some object variables, because remember, we're building a method of this MDN RNN class. And so the way we're going to do this is first create an object variable for the log mix, and so we're going to call that self.out log mix equals out log mix, right? Exactly this one, which already exists at this point. Then self.out, this time mean, is going to be equal to the out mean variable returned by the get MDN coef function. And finally, self.out log std, which is of course equal to this third variable here resulting from the split, right? Out log std. Here we go. We now have some object variables for the MDN parameters. Perfect. Now we're done with this MDN part of the implementation. So we're going to move on to the last and final part, which will be the same as what we did for the VAE, meaning, implementing the training operation. So let's put that new element of the structure right away. I'm going to go back here, and here we go. In the next tutorial, we'll start the implementation of the training operations. So it's going to be a bit more complex than what we did here, because we'll have to make some other functions inside the method, but we'll do it step by step. And so as soon as you're ready, let's tackle this. Until then, enjoy AI.